Hey everyone, I'm almost at the end of my journey through SFML books. Today we've got the fourth out of five books, SFML Game Development by Example, written in 2015 by Raimundas Pupius. It's almost twice as big as game development, over 500 pages, and right on the cover there is a 2D platformer, which is a really interesting game genre that none of the previous books really covered. So maybe this will finally be the first actually good SFML book. Let's find out. Previous books used features from the C++11 standard since they were written around the same time, but this book was written in 2015, which means it might include features from the C++14 standard. I'll disappoint you, it doesn't. Moreover, this book barely uses many things from C++11 either, such as smart pointers or the default keyword. It also still uses SFML2 instead of 3, so keep that in mind. If you want to follow along and rewrite the code from this book using SFML, you should use version 2, not version 3, because otherwise you're gonna run into compilation errors. Or, if you already more or less understand the differences between SFML2 and 3, you can just manually rewrite the code and fix the compilation issues yourself. At the beginning, the author says that throughout the book, we're gonna build several projects. First, a simple snake game, then some kind of platformer, and after that, we'll actually start making a full multiplayer RPG, which sounds super ambitious. So far, this is easily the most ambitious project lineup out of all four books. But are they actually gonna pull it off? I don't know. Because in the previous book, SFML Game Development, we spent the whole time building a project that was technically bigger than anything from the earlier books, but the author explained everything so badly that the project ended up feeling both confusing and kind of boring. So let's see if this author can actually deliver good explanations and interesting projects at the same time. Chapter 1. It's Alive, Setup and First Program. In the first chapter, the author tries to explain what the SFML library actually is, what modules it's made of, and how to add it to your project. I still think SFML Essentials handled this part the best, because that book gave a clear step-by-step setup guide, which unfortunately these other three books don't really do. But at least this author points readers to the official resources where there are tutorials on how to set everything up, so I guess that's good enough. And if you still don't understand how to install and link SFML after reading this book, you can always check out my SFML tutorials too. Unlike the previous books, this author at least clearly explains why SFML can be linked in two different ways, dynamically and statically, because the previous three books barely explain the difference at all. Here, we write the usual super basic first program where we create a window, and once again, it's weirdly tiny for some reason. Like this book came out around 2014, we already had full HD monitors back then, but the author still uses a 640 by 480 window for some unexplained reason. We also learn about the game loop, although honestly, it's explained a little worse here than in the previous books. The chapter covers double buffering, clearing the window, and drawing primitive shapes like rectangle shape, but the author doesn't really show any other shapes. What's weird is that he mentions classes like SF drawable and SF transformable, which the shapes inherit from, but then never actually explains those classes separately. So honestly, I'm not a huge fan of how this book introduces shapes either. There's already a small, simple, understandable class hierarchy for rendering these objects, so why not just fully explain the hierarchy and go through every class properly? That would only take maybe 5 or 10 pages, but the reader would come away with a much better understanding of how everything actually works. After that, we learn what an origin point is and how to place it in the center of a shape. Then we replace the rectangle with an actual sprite being rendered on the screen. So here the author quickly goes over what a texture is, how to load it from a file, what a sprite is, and how to connect a sprite to a texture. Nothing too complicated. He also shows a complete example where a sprite moves around the window automatically without any player input, just as a simple starting example for now. After that, he talks about common beginner mistakes related to the code we just learned. And that's basically where chapter 1 ends. What I don't really like is how rushed the whole chapter feels. The author covers a lot of topics very quickly, but doesn't explain them deeply enough. For me personally, everything was understandable. I already read 3 SFML books and I already have 2 SFML projects in my portfolio, so I get what's going on. But I still think this chapter could have been done way better. Chapter 2. Give it some structure. Building the game framework. This chapter, just like in the previous 2 books, starts moving into architecture improvements. First, we create a window class that wraps the actual SFML window object, handles switching between windowed and full screen modes, and generally starts organizing things a little better. And to the author's credit, this is where the book finally starts evolving a bit. The window size is now larger than before, although honestly, it's still nowhere near a reasonable modern resolution. After that, we create a game class that contains our window class and implements the basic game loop. So basically, everything we wrote in chapter 1 now gets wrapped into these window and game classes. Unfortunately, the same problem from the previous books shows up here again. There's code the author simply doesn't show. For example, in the previous chapter, we had a moving sprite. In this chapter, we keep using that same code, but the author never clearly explains where exactly you're supposed to place it in the new architecture. There's an online repository for the book where you can go digging for the missing code, but I can already tell that if this keeps happening in later chapters, it's only gonna get harder and harder to understand where certain pieces of code are supposed to go when the author doesn't explicitly mention them. Then the author takes a pretty big detour and starts explaining delta time. He goes into the history of game development a little bit, explains why delta time matters, talks about SF clock, how to use it, what SF time is, how that works, and then shows how to use delta time in the project so movement becomes frame rate independent and actually behaves correctly. He even tries to touch on fixed time steps, but honestly, SFML blueprints explained that topic much better. This book doesn't really nail it. There are multiple ways to handle delta time calculations, and so far, none of these books have done a perfect job explaining all the different approaches, but SFML blueprints definitely handle it better than the others. Chapter 3. Get your hands dirty. What you need to know. Now, this was actually an interesting chapter. Here we fully build a snake game completely from scratch in its most simplified form. And honestly, the author did a pretty solid job explaining how everything in the game is structured, all the classes and how they interact with each other. Sure, he still gives some pretty questionable names to variables and classes sometimes, and the architecture here is definitely pretty weak overall, but honestly, I'd say that that's actually to the author's credit in this case, because the focus should be on building small games first and then gradually improving the architecture as the projects get bigger and more complex. I also noticed a bunch of places where the code could have been optimized, but the author never points those out. On the other hand, he does intentionally introduce a few bugs just so he can explain and fix them later, and honestly, that's really cool. That kind of teaching approach actually helps. And after finishing the game itself, he even builds the first real UI element in the book, a text box that displays the player's health and score on the screen. So overall, I liked this chapter. You can basically think of it as the first chapter that actually combines and applies everything we learned in the previous chapters, but it's still not enough yet, so let's keep going. Chapter 4. Grab that joystick, input, and event management. This chapter honestly disappointed me. Turns out the author barely even uses C++11 in this book, so there are tons of raw pointers, manual memory management, old school random number generation, and a bunch of other outdated solutions all over the place. The previous books at least used C++11 properly, which makes this especially weird because this book actually came out later than the other 3. I guess the author just didn't feel like learning the newer standard. The entire chapter is also focused on improving the architecture, specifically by implementing an event manager, which is something I'm seeing for the first time after 4 books. And honestly, I hated it. The author massively overcomplicated event handling by creating these really clunky classes. Instead of introducing something like a game state architecture, where each game state could process input in its own way, he basically just added another layer of event processing and then tried to justify why it was necessary. Although maybe I'm just dumb and fail to recognize some genius architecture here. Still, I can at least praise the beginning of the chapter. The author actually gives a pretty detailed breakdown of how SF event works and how to handle different event types, including joystick events, which the previous books never even talked about. So at least that part was genuinely useful. Chapter 5. Can I pause this? Application states. Here, the author continues focusing on improving the architecture. Just like in the previous chapter, we keep using the movement logic from chapter 2, but this time the author introduces the concept of states, which I already mentioned in the last chapter. At first, I was actually kind of excited because this is a familiar architecture pattern from previous books, but out of all the game state implementations I've seen so far, this one is easily the worst. As usual, the author overthinks things and makes it way more complicated than it needs to be. The most painful part here is how events are bound from files into the game. It feels completely unnatural and out of place. That said, you do end up implementing a splash screen state, a main menu, a gameplay state, and also a pause state. And surprisingly, all of that is actually not that hard to rewrite, and the game still runs fine afterward. At this point, I'm slowly starting to learn toward the idea that this might actually be a bad book overall. On one hand, the author does introduce some useful ideas, but on the other hand, they're constantly buried under messy architecture and questionable code design. So, as usual, you get these small bits of useful architectural insight, but you have to dig them out of a pile of, well, let's just say not so great code. Nothing really new in terms of SFML itself shows up here either. Chapter 6. Set it in motion, animating and moving around your world. This chapter covers 2 main topics, working with the camera and animation. First, the author explains the SF View class, which is used to implement a camera system. I don't really have major complaints here, except that I would have liked to see a few separate focused examples showing how this class can be used in different scenarios, just to better understand how it works and what it's capable of. Then we move on to animation. Starting from this chapter, we begin building a platformer. You get introduced to the concept of a sprite sheet, and we'll be controlling a knight character that has multiple animations. And this part is honestly full of weird decisions. For example, the author writes an empty destructor and explicitly says it's empty, so why write it at all? Why does the author create a huge constructor that manually assigns default values to everything instead of just using in-class member initializers? Why does he write a function that takes a const unsigned int ampersand instead of just passing the value normally, which would actually be more efficient and simpler? Why does he add a base suffix to base class names? He could have just gone all in and called them base class or something equivalently redundant. Why cast enum values to short instead of the standard int when they'll just be promoted back to int anyway? And then there's the destructing Hungarian notation everywhere with prefixes like m underscore and l underscore on every verbal. On top of that, why store animation data in external files and then parse it back as strings and values instead of just defining a clean structured data type in code? Overall, the explanation of animation here is pretty disappointing. Yes, the author spends more time on it than any other SFML book I've read, but the implementation still feels unnecessarily messy and overcomplicated. Chapter 7. Rediscovering Fire. Common Game Design Elements. In this chapter, we finally finish building our platformer, and it's still far from a complete game, more like a prototype. Here you learn what tiles and tile maps are and how to work with them. This is currently the longest chapter in the book and also its most extensive section. I agree that this is important knowledge. It's a key part of building platformers or any game with a top-down camera, but honestly, the explanation is just poorly done. At the end, we try to combine everything we've learned into a single playable game, adding a player character, a rat enemy, and the different types of tiles with different behaviors. What I really don't like is the author's obsession with reading everything from external files. He stores literally everything possible in files, and it raises the question, why? Why not just keep this kind of data in code? This isn't game configuration or settings, it's literally world structure and character properties spread across dozens of files and not even in a clean way. He also briefly mentions the flyweight design pattern, and I expected a proper explanation of what it is, so why it's used and where else it appears, but no. That never really comes, so I still don't fully understand it. Another odd decision is how instead of storing tile coordinates as two separate values, he cleverly compresses them into a single index. It feels like unnecessary complexity just for the sake of it. On top of that, many classes are declared as friends of other classes. Usually that's a sign that the architecture is already in trouble, although at this point, I was kind of expecting it. And to make things worse, the code formatting is still very old, school, and messy, which makes it hard to read. I often had to copy it into Visual Studio just to make sense of what was going on. Overall, this is a very difficult chapter to follow. I still have a lot of unanswered questions about the code, and at this point, I think I can safely say this is a bad book, and out of the 4, it might even be the worst one. Chapter 8. The More You Know. Common Game Programming Patterns. Starting from this chapter, I thought the previous one was going to be the hardest. From here until the end of the book, we begin developing a multiplayer top-down RPG. It sounds ambitious, maybe even exciting, but also a bit intimidating because the same author who struggled to clearly explain a platformer is now trying to teach an entire RPG architecture. And my concern turned out to be justified. The author decides to use the popular Entity Component System, ECS, architecture for this game, and the entire chapter is dedicated to implementing it and integrating it into the project. First of all, the author doesn't restart the project or clearly explain what the existing code base is supposed to look like before introducing this new system. The same problem from the platformer chapter appears again, which makes it almost pointless to even try to follow or rewrite the code from the book. Second, the explanation of ECS itself is just bad and outdated. This is not how ECS is typically implemented today. The author massively overcomplicates the relationships between classes, adds tons of unnecessary abstraction layers, and in doing so likely even hurts performance, all just to demonstrate why ECS is supposedly better. But honestly, I never actually saw the advantages clearly explained. The author never properly shows the problem with the traditional class architecture approach that ECS is meant to solve, so I ended up spending an entire day trying to understand this huge mess of code the author created. Surprisingly, I did manage to grasp the general idea, but the way it was explained was terrible. At this point, I seriously considered dropping the book, but I was already more than halfway through it, and the ending felt too close to quit. The code remains just as outdated as messy as before, unnecessary type aliases everywhere, heavy use of deeply nested std pair structures leading to things like second.second or second.first. He could have used references or proper named structures to make this readable, but that never seems to occur to him. He also claims that components should only contain data, but then proceeds to add functions inside a component anyway, which breaks the whole ECS concept he's trying to teach. On top of that, he makes mixing null-ptr and null, switching between them inconsistently, which is interesting because that suggests that, that he does use some C++11 features. So he clearly knows the standard exists, but for some reason he avoids things like smart pointers, which would have reduced a lot of boilerplate code, probably because he didn't fully adopt or understand them at the time. And what about the actual game? Will there even be a meaningful result at the end? It seems like yes, there will be a landscape, a player, and an enemy. But what they're actually supposed to do is unclear, and honestly, I didn't even bother fully checking. At this point, I was just burned out. I kept rereading the same paragraphs without understanding them. Judging by the screenshots, you eventually end up with a map, a player, and an enemy. But beyond that, I have no idea what the gameplay is supposed to be. So let's just say this. I'm sorry to the stupid reader of this wonderful book who somehow failed to understand it. Chapter 9. A breath of fresh air. Entity component system continued. Yeah, the ECS implementation continues here. Damn. Alright. As far as I understand, up to this point, our characters weren't even able to move properly. In this chapter, we implement several systems that handle rendering, movement animation switching, and even collision detection. There are still some component details whose existence is poorly explained. Sometimes the author presents large chunks of complex code with a lot of logic inside, but only explains it in a few sentences, even though it would have made more sense to explain it step by step directly in the code itself. You might get shown a big algorithm and then receive a couple of vague paragraphs as explanation, which just isn't enough to really understand what's going on. And honestly, if you didn't understand anything in the previous chapter, you won't understand this one either. No real improvement in clarity happens here. Also, I don't even remember the last time the author introduced something new about SFML itself. It feels like the actual SFML part of the book basically ended up somewhere in the early chapters, which is kind of disappointing. Chapter 10. Can I click this? GUI Fundamentals. In this chapter, the author starts implementing a basic GUI hierarchy. Very basic, at least in theory. He first explains what a GUI is, and then immediately jumps into building a fairly complex system. And honestly, I keep wondering the same thing. Why not start with the simplest possible implementation? Just show a few basic elements first, like text, rectangles, maybe a button, and only then explain what problems appear when you try to scale it up. That would actually make the learning process much clearer. Instead, we get a pile of abstractions right from the start and only later try to assemble something concrete out of it. The only somewhat positive thing is that this system is a bit easier to understand compared to ECS. Still, it reuses ECS concepts, so if you didn't fully understand the previous two chapters, this one is going to be hard to follow. I also came across a piece of code where the author puts only a single field inside a union, claiming it improves performance, but honestly, that feels pointless. The optimization doesn't really make sense in that context, and it comes off more like unnecessary low-level tuning than something meaningful. Chapter 11. Don't touch the red button. Implementing the GUI. At this point, I completely lost interest in the book. If in the previous chapter we were implementing the base classes for the GUI system, then here we finally move on to concrete elements like label, text box, and button. And instead of things getting clearer, my opinion of the author just keeps getting more negative. Even the unnecessary philosophical intro at the beginning of the chapter starts to feel irritating. This chapter continues the same pattern of building GUI architecture in the abstract without any clear, practical examples of how these elements are actually used. There's no gradual increase in complexity. Everything is just dumped on you at once. The GUI classes themselves immediately come with a huge number of fields without any proper explanation of why all of them are needed. As a reader, you don't really see the final vision of the project, unlike the author, who already knows where everything is supposed to go. Because of that, trying to keep track of this entire architecture, which has been slowly built over 4 chapters without actually seeing it applied in a real working context, becomes almost impossible. He even stops showing header files at some point and focuses only on explaining method implementations. So the only real way to understand what's going on is to fully copy the code from the repository and slowly piece everything together like a puzzle. Chapter 12. Can you hear me now? Sound and music. This chapter became a turning point for me. This is where I decided to stop reading the book in full. Up until this point, I understood that I couldn't keep the author's entire architecture in my head, especially without even clearly understanding what stage of game development we were actually in. In this chapter, he decides to start adding sound to the game. This hadn't really been explained before, or maybe I just forgot. So at first, we get some genuinely useful and fairly simple information about how sound and music work in SFML. That part is actually good and necessary. But right after that quick bit of theory, he dives back into his usual architectural mess and adds yet another layer of complexity, a whole set of new classes for handling audio. And that's where I made the decision not to torture myself anymore, just skip the full implementation. I lost interest in building this game. At this point, it stopped feeling like learning. The author is basically just adding code and explaining it with superficial descriptions. Over and over again, the same mechanical cycle. Here's a new class, here's its implementation, here's another class, here's its implementation. It started to feel completely mechanical and repetitive. I was basically turning into a zombie while reading it, but there are still 2 chapters left and they focus on networking, so I decided to jump ahead there instead and try to find something actually interesting for myself. Chapter 13. We have Contact, Networking Basics. In this chapter, the author starts with a somewhat high-level overview of networking, sockets, ports, basic TCP and UDP concepts, and how data packets are sent over the internet. It feels a bit rushed and fragmented, but it's still more or less understandable. However, he doesn't really explain different architectural approaches for communication between 2 machines. Later on, he just implicitly chooses a client-server model. In other books, this theoretical part was handled a bit better. After that, the author introduces multi-threading, a notoriously difficult topic that really needs to be explained slowly, step by step, with multiple examples. Otherwise, the terminology quickly becomes overwhelming and beginners get lost. Did the author manage to do that here? Of course not. And the SFML related information sprinkled it in feels more like it's there just for the sake of mentioning SFML rather than actually teaching anything useful. Also, as far as I can tell, the book never really goes into shaders, which means the library is never fully covered. At this point, though, I'm not even surprised anymore. What bothers me most is that instead of first explaining why we even need networking in the context of the game, the author immediately dives into implementing yet another huge set of classes, so I skipped most of it. While skimming through the chapter, I saw separate client and server classes being implemented. And what's funny is that several dozen pages later, it turns out all of this was just to build a simple console chat application between 2 computers. So once again, this entire chapter doesn't even relate to the actual game. Chapter 14. Come play with us. Multiplayer subtleties. I didn't read this chapter. Here, the author just continues doing what he's been doing all along. inflating the architecture and stitching everything together. Occasionally, there are intermediate screenshots that are supposed to show what's been achieved so far, but they're misleading. Nothing actually works properly until the final code is complete. And on top of that, this is very likely the longest chapter in the entire book. And here's my final conclusion. This is the worst SFML book out of all 4 I've read. It includes the development of 3 projects, Snake, a platformer, and an online RPG. But the last 2 are basically just prototypes. There are only tiny fragments of their intended genres, nothing close to real implementation. No other book has ever worn me down like this one. Will you actually understand SFML properly if this is your first book on it? Not even close. Will you understand game architecture from it? Absolutely not. Yes, the previous books were also flawed in many ways, but SFML Essentials does a better job at teaching SFML itself, and SFML Game Development does a better job at teaching architecture. I really hoped that since I had already read 3 SFML books, this one would be easier to understand. I was even excited before studying it because I like the idea of working on game genres that hadn't been covered before. But no, this turned out to be another mess. Don't read this book. And now I only have one SFML book left to go, Beginning C++ Game Programming, 3rd edition. After that, I can finally move on to other areas of programming, and maybe eventually, if I get the chance, I'll even try to create my own SFML course where I show how it should be taught. Or maybe I'll mess it up too. We'll see. Thanks for watching this video. If you enjoyed it, leave a like, drop a comment, subscribe so you don't miss future book reviews and new tutorials. And if you want to support the channel, you can donate via the link in the description or become a sponsor to get access to practical lessons. See you in the next review. Goodbye.